Hi everyone and welcome back to our lessons. In today's lessons of parabolas, we are going to learn how to go from this form to this form, since you learned in the previous lesson that they are actually the same thing. So we want to rewrite it from ax squared plus bx plus c to the form of a in brackets x plus b squared plus q. We are also going to learn how to go from this form to this form. Now let's start with an example. Here we are given fx is equal to in brackets x minus 3 and then it's squared minus 16. Now if we are asked to take this form and rewrite it in the form of ax squared plus bx plus c, all that we need to do is we need to multiply this out. So as you can see, we've got two terms and this term is a product of two binomials, so we're gonna multiply this out, and you know how that works, right? So first times first is x squared, and then x times minus 3 is minus 3x times a 2 is minus 6x, and minus 3 times minus 3 is a positive 9, and we write down the minus 16. Then a 9 minus 16 gives us minus 7, so we end up with fx is equal to x squared minus 6x minus 7. Now that is all there is to it. Now why is this so important? Well, you can be asked in the exam to rewrite it from this form to this form, but it's also helpful because in this form we are given the coordinates of the turning point. This is the x coordinate of the turning point if we change this sign to its opposite, and then also this is the y coordinate of our turning point. By multiplying this out, we end up in this form, and this is also our y-intercept. Now let's go and have a look at how we can go from this form to this form. Now in the following example, we are given fx is equal to x squared minus 6x minus 7, and we want to rewrite this form into the form of a in brackets x plus b squared plus q. And we have to use the method completing of the square. Now when we have to use completing of the square, the method looks like this. So all that we're going to do is we're going to write down fx is equal to x squared minus 6x, and right between this x term and the constant of our original function, we are going to add a certain term, and we are going to subtract that same term, and then we're going to write the minus 7. Now, why do we add a certain term, and why do we subtract it, and where does it come from? Well, let's just make sense of this. Let's say, for example, you added 2 and you subtracted 2. Then it doesn't make a difference on the value of this function, because plus 2 minus 2 gives us a 0. So we are not going to change the value of this, but we are going to add a certain term and then also subtract the same term. Now let me show you where that term comes from, and we use this method when we are busy with completing of the square, okay? So let's see where this term that we're going to add and subtract come from. Well, this is something you have to memorize, and you have to memorize this for this method of completing the square. So here it is. You have to memorize b divided by 2 in brackets squared. Okay, so now where does this b come from? We go to our original function, which is in the form of ax squared plus bx plus c, and the b is a minus 6. So in the place of the b, we put this minus 6, and then it looks like this: minus 6 divided by 2 in brackets squared. Now, you do not have to do this calculation, just leave it like this, but then we are going to add this term, so there it is, and then we're also going to subtract the same term, and there it is. Okay, excellent. Now what we just did is we changed these first 3 terms that we have here into a complete square. Now when we have a trinomial that is a complete square, well, we're going to end up with 2 brackets that's exactly the same when we factorize it. But lucky for you, we do not have to factorize it. I'll show you a quick method to find that or those 2 brackets. So all that we do is we write the bracket, and then we will take, instead of x squared, we're just going to write x. So there it is. And then where does this next part in our brackets come from? Well, it's quite easy. We look inside this bracket, and all that we do is we simply say minus 6 divided by 2 is a minus 3. Okay, do not square it, just do the math inside the bracket. So we get a minus 3, so we write the minus 3, we close the bracket and we square it. And these are our two brackets that we have from factorizing this trinomial. And you can test it. Once you multiply it out as a product of two binomials, you should end up with this. Okay, so here we are. Now, where does the next part come from? Well, we just simply take these two constant terms, we type it into our calculator as minus, and then you put in the minus 6 divided by 2 in brackets squared minus 7, and you will see that once you do the calculation, you end up with minus 16. And there we are done. We just rewrote it from this form into this form. And we are done. That is how completing of the square works. Now let's look at another method which I call the turning point method. Now if you are asked to rewrite a function from this form of ax squared plus bx plus c into this form and they didn't tell you the method, well, you're allowed to use the turning point method. So all that we're going to do is we're going to write down fx is equal to x squared minus 6x minus 7. And from this form, you already learned how to calculate the turning point. So we calculate the turning point as follows. So it's minus b divided by 2a. And we get the y coordinate as 4ac minus b squared divided by 4a. Now, I'm not going to use this formula for the y coordinate. I'll show you another way to get the y coordinate. So we're just going to focus on the x coordinate. So we're going to write the minus, and in the place of the b, we put this minus 6, and there it is. And then we're going to take the 2, and in the place of a, we're going to put this 1. There it is. So once we do this calculation, you will see that the x coordinate of the turning point is a 3. Okay, so all that we need now is the y coordinate, right? So what we can do is if we have an x coordinate, we can simply put it into our original function. So we substitute it into this x and that x, and then we will get the y coordinate, right? So we write fx is equal to, and in the place of x we put the 3, so it's 3 squared, and then minus 6, and in this x's place we put the 3. And remember, in substitution we have to put the brackets in and then do the substitution. And once we multiply all of this out, we're going to end up with our y coordinate as minus 16. Okay, so the y coordinate is minus 16. And all that we need to do now is, since we have the two coordinates of our turning point, we can just go rewrite it in this form. So fx is equal to, so what is our a value? Well, in front of this x squared is a, right? So that's a 1. It's the same a in this example, so it's a 1, but I'm not going to write it down because 1 times anything remains anything, so just remember that. So there's our 1. Then we're going to open up a bracket. We're going to write x because that's the form that we want to find. And then this value is a 3, the coordinate, the x coordinate of our turning point. So we are not going to write a positive 3 in the brackets because we need to change its sign, right? So it's minus 3, and we close the bracket and we square it. And then we have the y coordinate of our turning point, which is minus 16. And we are done. See, we've got two methods to rewrite it from this form into this form. And let's go try another example. Now in this example, we have fx is equal to minus x squared plus 3x plus 18, and we want to rewrite this form into the other form by using completing of the square. Now why am I doing another example? Because earlier in the video I did not mention something very important. So pay careful attention. When we are doing completing of the square, we are not allowed to do completing of the square if this coefficient in front of the x squared is not a positive 1. This one is a negative 1, so I cannot do completing of the square directly. I have to do something first. I have to take out this negative 1 from each of these terms as a common factor so that this coefficient can become a positive 1. Now in another example, if I can say it, if we have 2x squared, we cannot do completing of the square. We need the coefficient not to be a 2, we need it to be a positive 1. So we're going to take out the 2 as a common factor. Now let me show you that method. So we cannot have a minus 1, we need it to be a positive 1. So I'm going to take out a minus 1 from each of these terms, like a common factor. So we end up with fx is equal to, with the minus at the front, and then minus x squared divided by a minus is x squared. A plus 3x divided by a minus becomes a minus 3x, and a plus 18 divided by a minus becomes a minus 18. And there we go. So we're going to just leave that minus at the front for whatever we do throughout this example, and we are going to work with what we have inside these brackets. Okay, so we're going to leave the minus, and then I'm going to write the bracket, and we're going to say x squared minus 3x, and between the x term and the constant we're going to add a specific term and then subtract the specific term, and we're going to write the minus 18, and we're going to close this bracket. Well, I know it's also known as parentheses, but I'm just going to use the word brackets. So there we go. So what is this term that we're going to add and subtract? Well, you remember it from before. We're going to have b divided by 2 in brackets squared. And what is this b? Do not go to this original function. Go to the one where we have taken out the minus already. So the b is now a minus 3. Okay, so that minus 3 goes into b's place, and we are just going to leave this term like this. And then we're going to add it, and there we go. And we're going to subtract it, and there we go. So now these first 3 is in the form of a complete square. So where do their brackets come from? So here's the difficult part. We have the minus, this bracket becomes a bigger bracket, and then this 3 is going to become 2 of the same brackets, right? So we're going to open up another bracket, and instead of the x squared, we're going to write x. Now, where does the next part come from? We use what is inside the bracket, so minus 3 divided by 2. Well, I don't want a mixed fraction, so I'm just going to use this improper fraction as minus 3 over 2. So we're just going to put it in as minus 3 over 2, close the brackets and square it. Then this part we are going to do on our calculator. So you're just going to type it in minus, you type in the bracket with the square, minus 18, and we end up with minus 81 over 4. Now we're almost done, but we cannot have these two brackets here. So this minus needs to be multiplied in with both these terms. So when we take this minus and we multiply it in with this 1 in front of this bracket, we end up with minus bracket x minus 3 over 2 in bracket squared. And if we take this minus and we multiply it with minus 81 over 4, we end up with a positive 81 over 4. And there is our form done. Okay, so a couple of very important things, especially you should not forget to multiply this minus in with both. If this was, for example, a 2, you have to multiply it in front of this bracket, and this will be a 2, and you're going to multiply the 2 with this entire term as well. Got it? Okay, so pay attention to all these small steps, and I'll see you again next time. Bye.